Hello everyone, welcome to NPTEL classes. Today I am here to solve Chemistry class 12th NCERT problem 2.31 from unit 2nd, that is solutions. Problem is based on concept of depression in freezing point, which is a colligative property which depends only on number of particles of solute in solution and not on the nature of solute. Now in the problem we have a situation wherein we are adding 3 electrolytes to water. First, acetic acid to water. Second, chloroacetic acid to water. Third, fluoroacetic acid in water. And after addition of 3 electrolytes to water, in hand we will have in hand 3 solutions. One solution of acetic acid in water, second solution of chloroacetic acid in water, and third solution of fluoroacetic acid in water. And question says that depression in freezing point for these solutions increases in the order as solution of acetic acid in water will have less depression in freezing point than solution of chloroacetic acid in water, and solution of chloroacetic acid in water in turn has less depression in freezing point than solution of fluoroacetic acid in water. So question is about this. Question gives order of depression in freezing point. Depression in freezing point, and depression in freezing point is represented by delta TF, and order is acetic acid, this is acetic acid. Solution of acetic acid in water has less depression in freezing point than chloroacetic acid. This is chloroacetic acid. And solution of chloroacetic acid in water has still lower depression in freezing point than solution of fluoroacetic acid in water. Acetic acid in water, chloroacetic acid in water, fluoroacetic acid in water. And this is the order of depression in freezing point. That depression in freezing point is maximum in case of solution of fluoroacetic acid in water and least in case of solution of acetic acid in water. Now we have to give explanation. We have to explain this order briefly. We have to give explanation. We have to briefly explain the order. All these represent solution of electrolytes in water, and for solution of electrolytes in water, depression in freezing point delta TF, depression in freezing point is equal to I KF into M, molarity. This is expression for depression in freezing point of solution containing electrolytic solute. If solution has electrolyte as solute in it, depression in freezing point in this solution will be calculated using this equation. Delta TF is depression in freezing point, I is Van Hoff's factor, and it is related with degree of dissociation of electrolyte. Kf is freezing point, molar freezing point constant. It depends on nature of solvent. M is molality of solute in solution. M is molality, that is amount of solute. Now for all the three solutions, for solution of for all three solutions, for three solutions, for solution of acetic acid in water, for solution of chloroacetic acid in water, and for solution of fluoroacetic acid in water. For these three solutions, some parameters are common. In the question it is given that amount of solute, amount of electrolyte, amount of acetic acid, chloroacetic acid and fluoroacetic acid is same. So M is common, M is same for all the three solutions. Now Kf depends on nature of water, and nature of water in all these three solutions is also same, water, and all these solutions are aqueous solutions, so Kf for all these solutions is same. Amount of solute is same. In the question it is said that amount of solute is same, so molality is same. In the question it is said that all three solutes are dissolved in water, so Kf is same. M is same for all three solutions, Kf is same for all three solutions. So dependence of depression in freezing point will be related, depression in freezing point will be related only with I. Delta TF will directly dependent on I, Van Hoff's factor. So for these three solutions, their depression in freezing point, the order of their depression, the increasing order of their depression will in freezing point will be explained here. I will explain it here on basis of difference in I value. And I is related with degree of dissociation, alpha. Degree of dissociation is equal to I minus 1 divided by n minus 1. Alpha is, because these three are electrolytes, they will have their own degree of dissociation. They will differ in their degree of dissociation. I said it is Van Hoff's factor related with degree of dissociation by this equation. N is number of particles formed after dissociation of 1 mole of electrolyte. When 1 mole of this dissociates, it will give 2 particles. One, this bond is polar, it will break towards more electronegative atom, oxygen, so it will furnish H positive ion in water and acetate ion in water. It will furnish 2 ions in water, H positive ion and acetate ion. This bond here, OH bond, is even more polar because of more electronegative atom chlorine instead of hydrogen. So this bond will easily break towards hydrogen. Here again 2 ions will be present in solution, H positive ion and chloroacetate ion. And this bond is even more polar than OH bond in chloroacetic acid because of most electronegative element fluorine present in it instead of chlorine or instead of hydrogen. So it will be most polar, it will break easily towards OH, oxygen, and here again 2 ions will be present in solution, H positive ion and fluoroacetate ion. Let us recognize nature of 2 ions present. In the solution of acetic acid in water, there will be H positive ion and acetate ion. In the solution of chloroacetic acid in water, there will be H positive ion and chloroacetate ion. In the solution of fluoroacetic acid in water, there will be presence of H positive ion and acetate ion, but their number will be different depending on degree of ionization, degree of dissociation of these three. Now uh, 2 for all these three solutions, n is same 2. And if I may write like this, I will substitute value of n equal to 2. 2 minus 1 will come equal to 1, so alpha will be equal to I minus 1. Basically I am trying to relate I with degree of dissociation. Now I will be equal to alpha plus 1. This is equation first, that depression in freezing point is related to I. This is equation second, that I is related to degree of dissociation. Now on basis of these two equations I will justify this is the increasing order of depression in freezing point. I will write degree of dissociation from first and second. I can write degree of dissociation will depend on alpha plus 1. Now first I can write basically three orders. First I will write order of electronegativity, that will decide order of degree of dissociation, that will decide order of I, and that will decide order of depression in freezing point. First I will write, this will be equation third. This is equation third. Now first I will write order of electronegativity. Order of electronegativity. Order of electronegativity in C X X X COOH. Order of electronegativity of X. Now X is variable. X is order of electronegativity here. X in case of chloroacetic acid is hydrogen. Its electronegativity is less than X. In case of chloroacetic acid is chlorine. Its electronegativity is less than fluorine. This is order of electronegativity, and order of electronegativity will decide order of degree of ionization, degree of dissociation. Order of alpha will be decided on basis of order of electronegativity of fluoride, fluorine, chlorine and hydrogen. So order of alpha will be chloroacetic acid CH3 COOH in solution of acetic acid in water. Degree of ionization will be, dissociation will be less than in chloroacetic acid. It will be less than in fluoroacetic acid CF3 COOH. Now order of alpha will decide order of I. Order of I will be as I depends on alpha. Order of alpha will be same as order of I. I may write acetic acid CH3 COOH less than CCl3 COOH less than CF3 COOH. This is the bottom line. That order of one, because in the fundamental equation, dependence of in the fundamental equation, in the basic equation, provided molality and KF are same for all the three solutions. Dependence on depression in freezing point, we rely only on I. So order of I will decide the order of depression in freezing point. Since order of I is acetic acid, solution of acetic acid in water has less I than chloroacetic acid in water than fluoroacetic acid in water. So I may right now answer that given order of depression in freezing point delta TF, given order of depression in freezing point, which is acetic acid, solution of acetic acid in water will have less depression in freezing point than chloroacetic acid CCl3 COOH will have less depression in freezing point than CF3 COOH in water and in water. So what was our problem? Our problem was that order of three electrolytes in order of depression in freezing point of solution of three electrolytes in water was acetic acid less than chloroacetic acid less than fluoroacetic acid. We needed to explain this order. I said that all these three solutions represent solution of electrolytes in water, and for solution of electrolyte in water, depression in freezing point is given by this expression. For all three solutions, amount of solute was same, so molality was same, solvent was same, water, so KF was same. So in all these solutions, dependence of depression in freezing point came only on Van 't Hoff's factor. Depression of freezing point, depression in freezing point of these three solutions will be different because of difference in their I value. Now I is related with degree of dissociation, and for these three solutions n is equal to 2 because number of particles formed after dissociation of 1 mole of acetic acid or chloroacetic acid or fluoroacetic acid was 2. I substituted here 2 minus 1 was equal to 1. I got the relation between degree of dissociation and Van 't Hoff factor for these three electrolytes, that degree of dissociation is equal to I minus 1. From here I expressed I in terms of degree of dissociation. I is equal to alpha plus 1. So depression in freezing point will depend on degree of dissociation. This equation says that depression in freezing point depends directly on I. This equation says depression in freezing point depends directly on degree of dissociation. I can explain my order on basis of order of I, or I can explain this order on basis of order of degree of dissociation. I wrote in sequence that first I will order of degree of dissociation will be determined by order of electronegativity of X. In first acetic acid X is H, in chloroacetic acid X is chlorine, in fluoroacetic acid X is fluorine. So order of electronegativity was H less than chlorine less than fluorine. On basis of this electronegativity order, I wrote order of degree of dissociation of acetic acid, chloroacetic acid and fluoroacetic acid will be acetic acid less than chloroacetic acid less than fluoroacetic acid. On basis of order of degree of dissociation, I framed order of I values. Order of I in solution of acetic acid in water will be less than solution of chloroacetic acid in water will be less than in solution of fluoroacetic acid in water. And I said, since in fundamental equation there is dependence of depression in freezing point on I, so order of I will decide order of depression in freezing point. Since order of I increases from acetic acid to fluoroacetic acid, order of depression in freezing point will also increase from solution of acetic acid in water to solution of fluoroacetic acid in water. So if you are asked which among the following three solutions will freeze at lower temperature, it will be fluoroacetic acid, because depression in freezing point in this solution is maximum. It will freeze at lowest temperature, and solution of acetic acid in water will freeze at relatively higher temperature. But all these three will freeze at temperature much below than freezing point of water. Freezing point of all these three will be lower than water, that is lower than 0 degree Celsius or lower than 273 Kelvin. And overall order will be freezing point of water will be less than freezing point of solution of acetic acid in water will be less than freezing point of chloroacetic acid in water will be less than freezing point of fluoroacetic acid in water. Class 12 students, this is what I have for you on this Saturday. See you on Tuesday with one new chemistry problem. Till then, take good care of yourself. Allah Hafiz.